Hello, good evening. Today is Thursday, July 9th, 2020, and I'm Bhavani from the University of Texas at Dallas. And what I'm going to do today is to give a presentation of what I gave at the Women in Communications Engineering event in Kona, Hawaii, in December 2019. I was one of the two keynote speakers at this event, Women in Communications Engineering, and it was held as part of the IEEE's Globecom conference. And so I'm going to share my screen. Okay, so the title of my Communications Engineering for a Woman. And so this link here, it describes the abstract of my presentation. And as I say, it was presented at the Women in Communications Engineering event. It was a workshop on December 9, 2019 in Kona, Hawaii, and it was held in conjunction or as part of the IEEE Globecom conference. Okay, so what I'm going to do is to first talk about what are some of the aspects. Why should women get into communications engineering? And then talk a little bit about my own research. So first, what is unique about communication engineering, say as opposed to other areas in engineering and computer science? So there are many aspects of communications engineering or engineering. It's at the intersection of electrical engineering and computer science, right? So you sort of get the best of both worlds. And it's one of the more lucrative fields in engineering, and it has high income potential. And communications engineering researchers and developers are in great demand, whether it be government, academia, or industry. So I've had a career. I worked at Honeywell, and there were quite a few communications engineering because they work in control systems and communication systems. And then I was at MITA Corporation for many years. And also they did a lot of work, research, development, and so on in radar systems. So communications is a key part. And then now I'm in academia, although I'm in computer science, I'm in the engineering school, and we have a very strong electrical and computer engineering department, and communications engineering again is a major aspect of the research area. And also I believe there's substantial funding with many agencies, both in research and education. And I would say this trend is expected to grow. But there are still very few women in communications engineering, just like they have in other engineering fields and computer science. So they make up around 20% or less, right? So if you look at computer science, some areas like cybersecurity, number of women, they are saying around 10%. But areas like data science, it's around 25 to 30%. So all in all, it's about 20%. So communications engineering, it can help humanity, of course. You know, at the heart of communications engineering is wireless networking, and it's a very intellectually challenging field. So here I am giving 10 reasons why a career in communications engineering for a woman. You know, you could also change this to a career like computer science, computer engineering. So communications engineering, what are the reasons a woman should get into? Given the opportunity, I would say women can excel in any engineering and computer science subject, just like men do. Okay, it's just that when you grow up, you know, when you are, you know, when your parents maybe And relatives and teachers, oh, they say, oh, you're a woman, you should go into some other field, not in engineering. But if women set their mind to it and work hard, they can be just as good as men. I'm not going to say better because we don't know. Of course, there are some women who are really, really good, and some men are very good also, but they can be just as good as men. Communications engineering is a very exciting field because of wireless networking and so on. So many innovations and developments happening so rapidly. When we look at our cell phones and mobile phones, smartphones, right? Communications engineering is a key aspect. It can be integrated with many areas: arts, humanities, natural science, social science, engineering, business, medicine, law, and the need for IoT and related technologies. IoT means Internet of Things. Why say, for example, medicine? Because you've got telemedicine, and without communications engineering, it's going to be really hard to do telemedicine. And right now we are all at home, at least most of us are at home, working from home. And what are we using? Zoom and WebEx and Teams and e-learning. And so I'm giving this presentation over Zoom. And we are using communications engineering almost in everything what we do. Communications engineering has many options, from research and academia to product development. As I said, many companies like Honeywell and Boeing and so on, they are into communications engineering. You can do startups, and there's substantial funding. And millennial women, right? And these are the women who were born, I believe, from about 1980 to 82 to around 2000 and beyond, right? So now I think we have the generation after 2000. I believe it's the generation Z or Z or Z. But generation Y, I believe, are the millennials. So millennial women and beyond have the flexibility and freedom to choose careers and have female role models in the field that us baby boomers never had. In many research areas, you can work from home most days, right? And that makes it ideal for a woman, right, to have a career as well as take care of the family and children. So continuing, why a career in cybersecurity for a woman? Actually, cybersecurity and communications engineering. So I'm sort of combining the two. Many communication engineering jobs cannot be overtaken by robots. We need researchers and developers to collect and analyze massive amounts of data from the IoT systems. So communications and information security, it's a highly paid field because you've got to look at security for communications, right? We are hearing about security for various, communication technologies. We are hearing about security attacks on Zoom. We really need to take care of it. So why not women take advantage of these benefits? Women can be financially independent with a career in communications engineering. Financial independence means self-respect, less stress, and confidence. I have always mentioned this to women, right? I've given several motivational talks to women in computer science, in data science, cybersecurity, and now communications engineering. Having financial independence, I believe, is a must for every woman. Communication systems are everywhere, from north to south, east to west, anywhere you go. Therefore, these systems can be attacked. You can make the world a better and safer place with cybersecurity, including addressing the major problem of violence against women and children with technology. Okay, so with mobile systems, smartphones, and so on, you can do surveillance of the various sort of children who are being abused. But on the other hand, you've got to be very careful when you do surveillance. Why? Because the privacy of the children have to be protected. It's sort of the safety, security versus privacy. And so there are technologies being developed like privacy preserving communications systems, privacy preserving data systems, privacy preserving, various types of surveillance and so on. So how do you balance security and safety with privacy for communications engineering integrated with cybersecurity. So my advice to all women, do not be undermined by others, right? So when they say women are not good in STEM, science, technology, engineering, mathematics, don't believe. That's only because women have not been motivated or encouraged to get into these very, intellectually challenging and financially lucrative areas. Never ever give up when others, even women, put you down. These women could have been your teachers or even from your home, because your parents may have given preference to, say, your brothers more so than to you. So do not give up. It could be teachers or it could be some colleagues, right, when they try to put you down. So you got to be motivated and have confidence. That's very important. But you've got to work hard. It doesn't come sort of automatically. You've got to set goals, but be flexible, as life does not turn out the way we want it to, especially with marriage and children. And I also like to add grandchildren. Why? Because, we want to do so many things, right? But we don't have, endless time. Time is the constraint. And many women, such as myself, we also want to get married. We want to have children. We want to have grandchildren. So, you've got to sort of balance. It never sort of ends, right? You say, when you get married, okay, and develop the career. So, okay, things are going to be okay, after the first couple of years, but then you have children and you are a mother for your entire life. So you've got the children, you usually come first most times. I mean, of course, sometimes you've got a really hard deadline, then you may want to ask your spouse or your mother or your friend to take care of your child so you can finish the deadline, but you're always a mother. And it doesn't end. So once the children go to college and they finish and they get the jobs and everything, and then you think, okay, that's it. So we can now relax a bit, but no, then you have grandchildren, then you've got to, help out your children. So life, what I'm saying is not, it's not really calm and peaceful and so on. We can make it to be, but there are external factors. So you have to be flexible. Love your work, but you've also got to enjoy life. Be a role model to the younger women and learn from the successful women. So, I try my best to be a role model for younger women, but I've also learned, I said that we don't, like us baby boomers, we don't have as many role models, but I did have a wonderful role model called Professor Marianne Porel at the University of Minnesota. So this was around fall of 1981. I was about 26 and she was about 52. So she was a brilliant career woman. Husband was also a professor. And she had a daughter who had just graduated, I believe, from college. Brilliant woman. And we did some joint research together. And she would advise me. She would say that just like, your marriage and motherhood, career is equally important. She said, do not try and do a balancing act, okay? She said, get the support. As they say, right, there was a book that was written, it takes a village to raise a child. And so I would say it's more like a universe, but you've got to get the support of your friends, of your family, trustworthy folks, so that you can manage everything, right? It's not easy, it's very hard, but you need a support system. Even though you may get into administration, which is very important to support women, right? Because and I'll give you an example in a minute, you've got to keep yourself technical and continue to do top quality research and development. Because only if you go up the ladder can you help other women, right? Because they say, say in academia, you need more department heads who are female, because deans are selected from that pool of department heads. So if you don't have as many female department heads, then the chances of having female deans are less. And the chances of having female provosts and presidents are less. So I would encourage the women as much as possible, if you can, if you like to, and if you want to get into administration, whether you are in academia or whether you are in a company. So I was a department head when I was at Mitre Corporation. And I was really good at it because in four something years, I grew the department from 8 to 28. And when you are in industry or even a company, say like Mitre, growing the department means you've got to find work for the people in your department, which means you've got to get funding. It's not like in academia where 9 months of the salary can be covered. So I was very good at it. However, I didn't really enjoy, I missed doing technical work. So after that, I went back to technical, but also kept leadership positions. And so when I joined academia 15 and a half, almost 16 years ago this October, I managed an institute. I'm still doing it, hopefully at least for another year. And, built up the Cybersecurity Research and Education Institute. So that's what I'm saying. Another thing I wanted to mention is that today you've got to be focused, because I had a great career from visiting faculty to academia to, visiting faculty to commercial industry, Controlled Data Corporation, Honeywell. Then I worked for a federally funded research and development center, Federal Lab, Mitre Corporation. Then I was 3 years with the government on IPA, National Science Foundation. And then I joined academia. So I've had a varied career, but I was fortunate. I've had an almost 40-year career this coming August. And so in 1980, when I started out, right, there weren't as many sort of women, or, there was a need. Computer science was really growing. But although it was competitive, I'm not going to say it was not competitive, right? Computer science was growing. There was a need also for more women. So I was able to sort of take detours in my career. But today, even though there are more opportunities, there are so many people now in computer science all over the world. So the competition is really, really, really tough. So I believe that you cannot afford to take detours, in your career. So you've got to be focused. So I tell the women, the one advice that they ask me, what can you say? I will say focus, F-O-C-U-S. Okay. Some suggestions for senior women. Support women on issues of importance, tenure-related matters, promotions, corporate boards. Because I've heard women say, the other women don't support us, right? Not all women, but some women do not support, because part of the reason could be that they don't want to be seen as favoring other women, right? Whereas they say, okay, men, they will support other men. So women are a little bit more careful, but you've got to support the junior women. Connect women technologies with senior personnel, both men and women. So you've got to find senior personnel, form that support group. So when I formed a very strong support group consisting of women, a few men, but mostly women. So for the senior women, so connect these junior women, right, to senior people. Mentor these women and give advice on career development. There are challenges, there are issues. Promote women for program committees, program chairs, and nominate them for awards. Of course, it has to be a fair process. They've got to deserve. Just because you're a woman doesn't mean you get the award. Okay, so nominate more of them for IEEE fellows. Only if you have 100 nominations. If you say 10% get in, there would be 10 female IEEE fellows. Help them with venture funding if you can. Promote women to take on administrative positions. Remember I mentioned only if you have more department heads can you have more deans, can you have more provosts, can you have more presidents. And in companies, only if there are more women first level managers, you can say department managers, you can have then division managers and vice presidents and president, right? So promote women to take administrative positions, very important, so that they can mentor junior technologists. introduce engineering education in elementary, junior, and senior high school. So we talk a lot about coding, C-O-D-I-N-G for girls, women who code, start girls into coding, so there are efforts like that. But engineering is, a lot more than coding. You've got to develop skills to engineer large-scale systems. And for that, engineering education is something that you can introduce to children in elementary school or girls in junior or senior high schools and train them into engineering. You can't say suddenly take an 18-year-old and say, there, do engineering, okay? And for those in communications engineering, you all have a wonderful special role model. Who can forget Hedy Lamarr, the most beautiful and brilliant woman? When many people hear of Hedy Lamarr, they think of her, as this most beautiful actress or actor in Hollywood. She was just gorgeous, and she was a good actor or actress, whatever you want to call it. She was wonderful. She acted in movies like Samson and Delilah. I watched that movie and I really liked her from then onwards. And then I heard, guess what? She is the one who has made Wi-Fi and Bluetooth possible for us. How did she do it? Because she's, I believe, originally from Austria. And when she was married to her first husband, I believe, so she would go with him to some meetings, right? And then she would listen to all these business meetings and mathematicians talking and so on. So she picked up on that, and she must have also read. And then she developed this spectrum technology, the wireless spectrum technology, the very, the very essence. So because of her, right, today we have cell phones and smartphones and so on. Now the question is, if it hadn't been if she was not there, would somebody else have discovered it? But that's not the point. She was there, and she applied for a patent with somebody else, and they got the patent. And that is what has given us Wi-Fi and Bluetooth. So not only does she have beauty, she's also brilliant, she also has brains. And so she is a special role model for women in communications and engineering, so that we can work on developing and securing her technologies, right? So these wireless technologies, we really need to focus on security. Cybersecurity is my specialty. And so this photograph I got from, those Hedy Lamarr photographs. Okay, so this is sort of the first part of my presentation to really stress the importance of communications engineering for a woman. And you can apply, many of the things I've said, except of course things like Hedy Lamarr and engineering education and so on. You can apply this also to computer science, data science, cybersecurity, okay, any field that we are really trying to motivate more of the younger women to get into. Okay, so now I'm going to talk a little bit about my own research. I have worked at the intersection of cybersecurity and data science / artificial intelligence since fall 1985. And that's 35 years ago when I was at Honeywell. Okay, so if you listen to some of my other presentations, how I got here, so for example, my talks at Women in Data Science at Stanford University in 2008. So I give a bit of background about myself. So anyway, I'm going to talk about how to integrate cybersecurity data science. When I say I've been working in this area for 35 years, at that time we didn't call it cybersecurity, nor did we have data science. We did have AI though, but mostly it was expert systems. Data science was more data management, and cybersecurity was called computer security. Okay, so I do have a chart. How did I get here, right? I am a Tamil from Sri Lanka, so I call myself Sri Lankan Tamil ethnic origin. I got married at 20 in 1975. I was finishing my undergraduate degree in mathematics and physics at the University of Ceylon. Sri Lanka used to be called Ceylon. My husband, he's also of Tamil origin. He was finishing his PhD at the University of Cambridge, England, in the UK. And so we get married, and then we moved to Bristol, University of Bristol. Soon after, I start my graduate education, and then I moved to the US in 1980 because my husband and I felt there were much better opportunities for us in the United States. So I was offered, my husband was working at the Petroleum Recovery Research Center in New Mexico. And so I was offered a job in my first meeting right away. The department head said, tenure track faculty position. And he also mentioned a very good salary for that time, for 1980. Assistant professor at New Mexico Tech. He was in Socorro, but declined it because my son was a baby. So I felt that I couldn't really cope, right? Have to take care. I didn't want to leave my son with babysitters and daycare centers. I really didn't want that. Because for me, for some people it works. I have nothing against daycare centers because sometimes it could be a wonderful place for children and babies to, meet other children and so on. But for me, I felt that it didn't work for me. And so, so I took visiting faculty positions. And then we moved to Minneapolis. My husband joined 3M company. So I was at University of Minnesota, continued with my visiting faculty, because once you turn down a tenure track faculty position, it becomes that much harder, right, to get into tenure track faculty positions. So I was visiting faculty for 3 years, and then I really wanted to get into industry, so I joined Control Data Corporation as a senior developer. So my lucky break came in 1985 fall, because that's when I was eligible to become a US citizen 5 years after I got to the US. So I applied. Honeywell won the US Air Force contract, right, to design and develop secure database systems. And so Honeywell had just written the proposal, so they were not sure whether they were going to get the funding or not. So Honeywell interviewed me. All three things had to come together. So I had to get my US citizenship. Honeywell had to like me in the sense to hire me, and they had to get the contract. They had to win the contract. So all three things came together. And I've been working in cybersecurity and data science, MITRE, Honeywell, NSM, UT Dallas for almost 35 years. I put 34 years because when I gave the presentation in December 2019, it was 34, but this September, it's going to be 35 years. Okay, so what's my area? I do a lot of work on big data management, security, and privacy. So what's big data? Massive amounts of data. Due to technological advances, okay, novel applications, it is possible to capture, process, analyze large amounts of data for security tasks, or even other types of tasks, right? You need even to manage massive amounts of data for authentication, access control, anomaly detection, user monitoring, protection from insider threat, as well as other applications like financial applications, healthcare applications, lots and lots of data. Analyzing and integrating data collected on the web, we can identify connections and relationships and so on, especially with COVID-19, right? Lots of data we need to analyze and predict. Where are the next hotspots going to be? What are the best treatments? And even to develop vaccines, you may have to analyze lots of data. What are the appropriate medications and the vaccines and so on? Protecting our homeland. So this data that you collect, even if you anonymize by removing the identifiers, like so-and-so has gotten COVID-19, and you may not want to tell everyone. But when you link it with other data, right? This person has been in a COVID-19 ward and may lead to re-identify the individuals, right? Security tasks such as authentication and access control may require detailed information like multi-factor authentication. The information, if misused or stolen, right, your user ID and password and all the stuff, can lead to privacy breaches. So lots of work now. Directions include securing the data, access control model. There's also privacy enhanced techniques, big data analytics for cybersecurity, and so on. Okay, I'm going to talk a little bit about these areas. So there is this movement called privacy aware quantified self. There's a movement called quantified self, like psychologists and so on are working on it. So what they want to do is to collect all the information about a person. Imagine the privacy, right? Because you want to collect information about the person for healthcare reasons, right? Because if we know every little thing about us, right, then something like COVID-19, we may have some idea whether it's going to affect us in certain ways if we do get the virus. However, if we have all this information, health-related, fitness, location, social media, image, videos, other sources, right? So what happens is that it could be a disaster with respect to privacy. And so there's data collection. You store the data, maybe on your smartphone, and analyze the data, share the data. And some of the data encrypted, it can go and be stored in a cloud storage. There are cloud-based services, anonymized and so on, and you work with encrypted data. So what we said was, we want a privacy-aware quantified self data management framework. So what that means is that at every layer, data collection, okay, you want privacy-aware data collection. Policy-aware, there are policies that will guide us, right? How to share the data. And collect the data. Policies will guide us how to store the data and access the data. Policies will guide us how to analyze the data and then how to share the data. So again, when we talk about policies, we've got to work with those who are experienced with policies, because we do a lot of work on security policies, but we are not policy experts, right? So our policy work, right, we have TOY policies. But when we work with policy experts, they do know what sort of policies to enforce. And so we work with them to develop this policy-aware, policy-based, privacy-aware framework. Okay, so that's from a privacy point of view. From data science or AI for cybersecurity applications, what we have done is worked on stream classification. So essentially what we do, use the past data to build a classification model that can predict various labels of future instances using the model. So this can help in the decision-making process. So these are data streams. They are continuous data that's arriving continuously. This could be sensor data, right? Like from our cell phone, lots of data could be bits and bits of data could be continuously arriving, or from sensors, surveillance data, or it could be stock market data. What happens when you have continuous data, right? You cannot use a static model because the concepts are going to be changing continuously, right? Data collected today, stock market data, some company could be doing really well. Last week, that company may have done very badly. And next week, that company could perform superbly well. So concepts are changing, right? Very common, but so this kind of data, very common in the digital world, massive amounts of data. So what we do, so network traffic also is an example of streaming data. And so we get the data, we develop a classification model, training data, and then test the data. If it's attack, we stop. Then benign, that's fine. And then periodically, our model is updated. Because, why is it updated? Because one model cannot last for even 2 days or 2 years or 20 years. So you could have, model could be changing every 2 hours maybe. So you've got to keep changing the model. So I've also given some directions to our papers, some references. Okay, so here's another example where we applied this technology for insider threat. Insider threat, these are really people who are really bad people, but they are part of the organization. So they pretend to be good people. And do all kinds of bad stuff, right? They do espionage, but that's in terms of humans. But inside a threat could also be processes in the system. So these are malicious processes that pretend to do good things. So what do? We develop supervised and semi-supervised, unsupervised algorithms. So you look at various system calls. So you look at I+1 chunks. So data is coming, streaming data, we look at chunks, and then we develop models, right? Extract features, those of you all who know machine learning, extracting features, and then when the kith chunk comes in, so you develop models, ensemble of models. So we don't develop just one model, collection of models. And so these models are changing. So as more data comes in, some models are thrown away because they are outdated, and some models are going to be updated, and some new models are going to be integrated. So anyway, the I chunk comes in, we do the same thing, extract features, apply these algorithms, and apply like support vector machine, an algorithm we use all the time. And then if it's an anomaly, right, it's an anomaly. If it's not, then it's not. But we use that information continuously to update our models, okay? So I also have given the reference here. So that's our work on applying data science AI for cybersecurity. In particular, machine learning models for cybersecurity. Here, it's something quite different. What does that mean? What happens if these machine learning techniques could be attacked? Whether we are applying for cybersecurity or whether we are applying for healthcare, such as COVID hotspot detection, or financial information, such as which stocks are going to perform well, regardless, if these machine learning techniques could be attacked, they could provide sort of garbage outputs, and that could be disastrous, right? You could say that COVID-19 could be really bad in, say, Lincoln, Nebraska, instead of Houston, Texas. Right now, Houston, Texas is turning out to be a hotspot, right? So you don't want, so when things were really bad in New York City, you know, if the model had said Lincoln, Nebraska is where you got to, I'm just throwing it, Lincoln, Nebraska is the city that you got to focus on, instead of you know, Houston, Texas, then you put your resources in the wrong place. So the point here is that if the machine learning technique that's doing these predictions are attacked, right, then it could be a disaster. So it's not about so this whole area has come to be called adversarial machine learning. It's not about changing concepts or online learning. Essentially what the adversary does, it's adapting itself to avoid being detected. So it's going to learn about our data and our models. What's the data that we are using to train our models? And what is our model? And then based on that, it's going to adapt itself and might even attack our data and our models. Our data could be attacked, the data that we are using to train the models. So if our data is attacked, giving us bad data, our models are not going to be accurate. So over time, we figure out what the adversary is doing, right? And then we try to modify ourselves. Then the adversary catches on. So like, for instance, the blue ones here, blue circles are the good instances, and the red squares are the bad instances. And this is the boundary line for support vector machines. And what the adversary is trying to do is to push all these red squares, make them into blue when they are not, pushing it because they have adapted their schemes, okay? So look what they are doing. They are pushing the red below the boundary. And so we will now not detect these red squares here. We will only detect these red squares. And so they have really done a good cover-up job. Okay, so that's support vector, that's adversarial machine learning. And what did we do? So here's an example. So a threat model, attacker modifies a test time deployment, attacker modifies, say, X to X prime. It can modify various things, packet length by adding dummy packets or adding good words to spam email, adding noise to an image, and so on. So here we have a blue, a support vector machine. This was actually our original support vector machine. So we do boundary line. We do a lot of mathematical computations. It's not straightforward. It's in our paper here. It was one of the early papers on this subject. And we push this line. And here, it's a blue line, right? So we learn what the adversary is up to, because adversary has first learned about us and it's modifying its behavior. So we figured out. And so instead of the boundary being here, our boundary is changed. So what happens then? So see, green circles are the good instances, the red crosses are the bad instances. So when we move the boundary line, more of the bad instances could be caught. Because here, these bad instances would not have been caught if we had not moved the line. But we move the line, so the bad instances are caught. But what we can do, if we are not careful, we can move the line right up here, so everything will look bad. We don't want false positives or false negatives. So the challenge for us is to use appropriate mathematical techniques to come up with the appropriate boundary for the support vector machine, so that enough of the bad instances could be caught. Okay, because we want to catch the bad guys. That's the main goal. But on the other hand, we don't want all the good guys to be caught as bad guys. You see, so false positives, false negatives. So that's the challenge. And the thing here is that we have only handled this particular picture I show here is for one type of attack called free range attacks. In reality, there could be hundreds of attacks, right? So how can we handle all the attacks? Because we, as defenders, must handle the situation, right? We have to protect from every type of attack, which is very hard. The attackers, all they have to do is to get in, just get in one instance and attack us, and it could cause really a chaotic situation, okay? So that is what we are faced with. It's a huge problem, challenging problem. We made some progress, and others are also very actively working in this, but a lot of work to be done here. Okay, so this is my last chart, I believe, or one before the last. So what are the directions? Developments in integrating cybersecurity, AI, or data science, machine learning exploding. Applications of AI for security in cyber threat detection, and security for AI, adversarial machine learning. Also developments in privacy-aware healthcare and managing one's life activities. Privacy-aware quantified self. Sorry, not quality, it's a spelling error. Quantified, Q-U-A-N-T-I-F-I-E-D, quantified self. At the same time, with the development of the IoT, Internet of Things, including, there's also now Internet of Transportation and Infrastructure, right? AVs, autonomous vehicles. Security and privacy solutions are being developed, mainly physics-based solutions. Physics meaning, for autonomous vehicles, I work with co-advised a PhD student who recently finished his PhD. He came up with some physics-based solutions, physical properties like the accelerator and sort of various physical properties, came up with some solutions. So the question is, how can we bring AI into it? As driverless cars become a reality, more and more of the AVs will use AI machine learning techniques. So how can we develop AI solutions for detecting, say, malware in AV systems? And how can adversarial machine learning work in AV, it's autonomous vehicles? Can we develop a privacy-aware policy-based data management framework for, say, transportations and infrastructure? I'm using transportation as an example, okay? It could be healthcare applications. So I'm looking at cyber physical system applications. Is it possible to perform trustworthy analytics, right? There are Intel chips, trusted execution environments that Intel's coming up with, where you can have enclaves of areas where you can carry out trustworthy computations, right? So can we do that? Data is coming in all directions. So what I'm saying is numerous opportunities, for substantial research and development, and these are really critical areas, and it's only going to boom. So coming back to my earlier topic, women in communications engineering, especially in these autonomous vehicles and transportation systems, there's a lot of engineering there. You need to have a good understanding of control systems, engineering, communications, engineering, and so on. And here you can integrate AI and cybersecurity, right, for communications systems and autonomous vehicles. So essentially AI, cybersecurity, and control engineering and communications engineering all coming together. And there are a lot of opportunities for women. And these could, very high paying jobs, and more importantly, intellectually challenging jobs. Okay. So as I said, I worked for 40 years, right, this August. And I started my career when I was 25, as soon as I finished my PhD. And so this 40 years, even today, right, there have been many benefits, monetary benefits and prestige and, getting several awards and so on. But what makes me happiest with respect to my career, of course, is when I sit down and just a few hours sit down and read a paper, learn something new, and expand my mind. I think I get so much satisfaction and happiness, actually, when I do that, right? Of course, all the rewards, monetary rewards, and all the accolades and the prizes and so on are great. But, there's only so much, because the more you get, the more you want, right? You're never satisfied. That's human nature. So, if you are earning a lot, you want to say, okay, how much can I improve on my salary? Or if you're getting awards, how many more awards? You want more and more awards. But you see, while that's important, because you've got to earn a living, right? But for me, sitting and reading a paper, spending an hour, I try to do that at least 1 hour a day. Set aside 1 hour. But if the 1 hour turns to 4 hours, great. But sometimes I don't have the luxury with so many things to do to have 4 hours of time to just sit down and study, because there are papers to write and lectures to prepare. Because after this talk, I'm going to prepare my lectures with some of the lectures. I've finished 2 of them, 1 of them, because I teach from 1 to 5 on Friday afternoons during the summer. So, and that's on analyzing and securing social media. So there's many things to do. But coming back to the main point, when I sit down and read and try to enrich my mind, I think that gives me so much happiness, right? And that's what really keeps me going and motivated. As I said, I'm very thankful to have had a 40-year career, and I wish I could work for another at least 20 years. Okay. Of course, I've got my other things to do, with family, but it's combining family and career, taking care of my son, and now I'm also a grandmother. And so combining all of that and having a career for myself, that's really wonderful. And then you can also be a role model for your children, especially girls, and your grandchildren, granddaughters, right? And those of us who have sons and grandsons, I would say, tell them, when they are in the cradle, that women are as good as men. They can do anything. So, you can't talk about diversity and inclusion when a man is 18 or 25 or 40. No, it has to start at the cradle, right? Motivate the women and girls and tell the men right from the time when they're in the cradle that, whatever they can do, their spouses and their daughters and their sisters and their mothers, they can do as well. Okay. So, right. So I work very closely in this area with my 2 colleagues, Murat Kantajlu, who is an expert in adversarial machine learning, and Latifa Khan, who is an expert in applying data science for cybersecurity. And Rhonda Walls is our project coordinator, who sort of provides us with excellent support so that we keep going, right? So I've got my email addresses. So again, thank you very much for listening to these presentations. So as I said, again, going back to my original theme, this was about the talk I gave at WICE, Women in Communications Engineering. So communications engineering, as I've said, it's an ideal field for a woman, high-paying field, intellectually extremely challenging. And so what I'm saying is it's something that's, it's really, important field and something that's challenging, and it's something that women should, it's an ideal career, area for a woman to get into. And I also said we have a role model who is Hedy Lamarr, beautiful and brilliant. And then I talked a little bit about my own area for the last 35 years, integrating cybersecurity and data science / AI. It used to be computer security and data management / expert systems. And again, I want to encourage every woman out there, be motivated, be enthusiastic about your work, and most of all, for the younger women, you have to be focused. Okay, thank you very much. Stop.